Welcome back. So the last time we were together, we worked on geometric mean, which was super simple, right? And then we did these triangles where we had a right triangle and we drew an altitude, and then there was like 3 triangles and they were all similar and we had to figure out which side was corresponding to which side, and I went home and I had nightmares. Did you? Me too. So having nightmares, my wonderful coworkers came in this morning, saw me a little stressed, and she goes, "I totally got you. I found 2 shortcut theorems here. Here they are." And I went, "Oh, okay." So without further ado, here are our shortcut formulas. You ready? The first one, geometric altitude. So we're going to use that, but it's with the altitude. Okay? So what this says is if we've got a right triangle with an altitude, the length of this altitude is going to be the geometric mean, which is exactly the stuff we did last time, the square root of the things multiplied together. And the things are the 2 segments that get created on the hypotenuse by the altitude. So those 2 things, that's what you're taking the geometric mean of. And that's the length of this altitude. Okay? So length of that altitude is the geometric mean between those 2 segments that got created by my altitude. All right? Let's go into the examples from last time. Okay? So here's the examples from last time. We're going to start with number 1. If you have room to do any more writing on your work from yesterday, just go ahead and add to it. If you don't, then on the back of today's notes, it's a full blank sheet. So you should be able to just kind of quick redraw it. Okay? So this is number 1 from yesterday. Here's our altitude. And here's the hypotenuse cut into 2 different pieces. And so the formula says that the measure of the altitude is equal to the geometric mean. That means square root with a multiply in it. The geometric mean between one side of the hypotenuse and the other piece of the hypotenuse. Which means this is the square root of 3 and we're done.
Yay, that's simple.
Isn't that way easier than yesterday? Oh God. If you understood yesterday even like this much, a little bit, you got this.
So just
Yeah, just that. Let's do it again with number 2 so that you can see how stupid easy this is.
don't simplify.
No, that was already done. Yeah, we can't simplify this more because that does not have a whole number square root. All right, let's do number 2. Here's our altitude, which means we're looking at the geometric mean between that segment and this segment. That means that the altitude is equal to the geometric mean between this part of the hypotenuse and this part of the hypotenuse. And so the value of x is, that's it, you're done. That's it. I want to show it to you on number 4 because number 4 looks like it's going to be a little more cray.
So we don't simplify the 10, right?
If you can. Okay, so the question was, you don't simplify this, right? Question mark. And the answer is, if you can simplify it, you must simplify it. So it does 10 have a whole number square root?
No, it doesn't.
Does it have factors where one of them is a whole number square root? Then you can't simplify it, so there's nothing to do.
Oh.
But if it was a yes to either one of those questions, you would have to simplify this. Okay? Let's look at number 4, because number 4 is a tiny bit cray, but still kind of easy. All right. Let's do this. There's the altitude. There's one piece of the hypotenuse. There's the other piece of the hypotenuse. And my shortcut theorem says that the measure of the altitude is equal to the geometric mean between one piece of the hypotenuse and the other. Which means this is the square root of 3. The square root of y is the square root of 3. How do you undo a square power? How do you undo a square power? This was a question yesterday.
You multiply it by itself.
Okay.
Which
Listen, okay. Ignore this, listen to the question. How do you undo a square power?
You square it.
Square root.
You square it?
You take the square root. How do you undo a square power? Take the square root. How do you undo a square power?
Take the square root.
I have a square root that I'm trying to get rid of. How would I get rid of a square root? Use the square power. Because it undoes each other. To get rid of a square power, you take the square root. Well, to get rid of a square root, you take the square power. So I'm going to take the square power of both of these sides of the equation. So I'm going to square this side, and I'm going to square this side. Now, when I take the square power of a square root, they undo each other, which means this thing and this thing are going to go away, and so all that's left for me is that piece inside. And y equals 3.
3 equals 1. Whoa.
Easier than yesterday?
Yeah.
Good. Do you want to see one more, or are you good on this shortcut and want to see the next one?
For that one, since it was 1, we could have just put 3, right?
Is this good?
Yes.
Okay. Can I have my notes back? I need a
Yes,
color. Thank you. All right, second shortcut. Again, uses the geometric mean. So again, you're going to find two values, multiply them together, and take the square root. But this has to deal with the leg. A leg of this triangle is the geometric mean between the length of the entire hypotenuse and this piece of the hypotenuse that's next to that leg. So the measure of the leg is the geometric mean. Multiply them and take the square root. Between the entire hypotenuse of the right triangle and the little tiny piece of the hypotenuse that's touching the leg that we were looking at. Okay? Let's go back to our examples from yesterday. We're going to look at number 2, and we're going to redo number 2 from last time with the, so that you can see we get the same value, but we're going to use the shortcut to see how much easier it was than yesterday. Okay? Here we go. Here's number 2. Y. Is it a leg?
Yes.
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 So that means that the measure of y is the geometric mean between the entire hypotenuse.
Just 25.
It's not 25.
Wait, isn't it?
Hang on, slow down.
Oh no, I'm looking at different ones.
Okay. The entire hypotenuse times the little piece of the hypotenuse that's touching the leg. I got 7 because I added 2 and 5 together. And that's what we got yesterday. But yesterday we had to like find the proportion and the cross multiply and the, oh God, way too much, darling. All right, let's do it again, but with Z, so you can see it on Z. All right, so I'm going to find the measure of this leg. Our formula says the measure of that leg is equal to the geometric mean of the entire hypotenuse length times the piece of the hypotenuse that's next to that leg that I'm interested in. That's it.
Well, simple.
That's all there is to it, man.
Man, this is as easy as ratios.
Because I gave you a shortcut. Because you were able to follow the really complicated one, as soon as I busted out the shortcut, it was like, psh. Okay. I would love to show you
Number 4.
number 5.
Ooh.
Okay? And I want to go back to the very first shortcut that we did. Because it has something similar to what we did in number 4, but I want you to see it again. Okay? So you don't freak out. Altitude, piece of hypotenuse, piece of hypotenuse. I'm not looking for the leg length. I've got altitudes and hypotenuse. I don't have leg and hypotenuse right now. Okay? So I have altitude and hypotenuse. So that's going to be the altitude is equal to the geometric mean between the two pieces of the hypotenuse. How do we undo a square power? Excuse me, how do we undo a square root?
Square power.
A square power. I'm going to take the square power of both sides. I didn't write down the scratch work of taking the power of everything. I just wrote the result. Is that okay? Yes?
Boom.
Yes? Yes? I'm looking around. Is that okay? Okay. And then divide by 2 and x is,
2.
which is what we got. Did we do that one yesterday? I don't think
No.
we did. All right. Feel good?
I feel great.
Do you need any more examples or are you happy with us?
I'm
That's a
happy.
lot easier than.
Right? I
I
know.
don't even remember yesterday's. 'Cause I was just,
Because it was way too complicated.
yeah,
Why do I make life so
I
complicated?
was just like corresponding sides. Putting
Yes. Good. All right. That's all that I had.